Actually, let's try to play a small game. Okay, suppose you find a big bag of gold coins in your backyard. So what do you do first? Okay, you'll be rich, right? You'll find a very big bucket of gold coins, many of them. What the first thing to do? Count them. Yes, pick them up. Okay, pick them up and okay, hide somewhere. Okay, and count them. Okay, give them value. And maybe first of all, we need to know how many we have, right? We have many of them. So how do we count them? And how do we use some symbol to represent the quantity of these coins? Okay, what do we count? Just think about in olden days, in ancient, okay, thousand years ago, we don't have language. What do we count? We don't have any language. And what we have, we don't have computer, we don't have pen and pencil. How do we count them? What we have is 10 fingers, right? We have is more convenient. Count board. Do we have count board 1,000 years ago? The most convenient is just grab fingers, right? Then something older. That's interesting. Just use whatever is available. The most available thing is your fingers. Okay. Think about we all have 10 fingers. Okay. Abacus. So rocks. Okay. Okay, let's think about use fingers. Fingers, we have 10 fingers, right? So we count 10 fingers. We can count from 0 to 10 for one human being's hands. How about the more than 10? More than 10 fingers. More than the number is more than 10. We don't have a second, third hand, right? In that case, we have to use additional location, okay, to represent the overflow number. Okay. So basically, this location, each number represent 1. Okay. And the next one has different weighting. Each one number represents 10. Okay, this is what we can do because we have a base 10 system because human being has 10 fingers. Okay. So how many do you know in our language? Okay. This is a base 10 system. So if you count, will be 64. Okay, this is what we can get in our human beings system. We call decimal numbers. Decimal numbers, each bit represent in this location represent 1. Okay, next one, each one represent 10. That's why we call the base 10 system. All right, so this is 64. And actually, if we have more fingers, okay, if we are Superman, if each of us has let's say 16 fingers, what's the number now? Okay, so this one, each number represents 16 because if we have more fingers. In that case, this location we can count up to 16, but 17 we have to do a carry. Okay, and this second location, each number means 16. this location, each number means 1. Okay, good. So in that case, we can count how many times here. Each times 16, we have 64, which means we have 4 times carries. Here will be 4, here will be 0. So this is a new numbering system, which has a base of 16. Okay, makes sense? So which means give you an idea to represent a quantity. We don't have to have use base 10 system. We could have different base system. All right. So this one actually later we are going to discuss. This is called hexadecimal system. Okay, makes sense. Just one more example, maybe 2 more examples. If we only have 8 fingers, okay, what will be the new number? So this one, each one represents 1, and this one represents 8. So 8 times, okay, if 2 0 means it is 16. Okay? Each one times 8 will be 16, but we have 64. So what can we do? That's interesting. Okay. For 2 should be more than that. Okay. Okay. So we need an additional bit or location. Okay, just give you an answer. Later we are going to discuss this. So this will be octal number, just has a base of 8. Okay. Yeah. One more to go. So if we have just 2 fingers, okay, like a machine, like a robot, they only have 2 fingers. Okay, either 1 or 0. So two numbers for each location. I just write down the answer. 64 will be this 6 zeros. Okay, which means a different base system has different numbers. We can represent the same quantity. So this is what we are going to learn today. Just give you some ideas. We don't have to use decimal. We can use different number system to represent the quantities.